Welcome to part 2 of Radar School. I'm John Cameron. Last week, Chief Meteorologist Michael Bowling explained the basics of how radar works. Radar is a critical tool used to analyze Texoma sky, especially when weather could be life-threatening. And while radar is fairly simple to understand, it takes an experienced eye to properly analyze and communicate what those blobs and colors are on the radar screen. Now, there are 3 modes or products commonly used during severe weather. They are reflectivity, velocity, which uses the Doppler effect, and correlation coefficient, a relative newcomer in the radar game. In today's episode of Radar School, we're going to focus on reflectivity. It's probably what comes to mind when you think of weather radar. Showers and thunderstorms displayed as multicolored blobs marching across the screen. Now, did you know that radar is an acronym? It stands for radio detection and ranging. That means it uses radio waves. They're sent out in short bursts from the radar in all directions. Now, if there are objects in the path of those pulses, like raindrops, bugs, or wind turbines, those waves bounce back or reflected back to the radar antenna. This is why showers or thunderstorms are often referred to as echoes. All right. In the same way that the science of our skies is fascinating, there are some incredible fun facts about radar. For example, your typical household microwave generates about 1,000 watts of power, while a weather radar transmits around 500 to 700,000 watts in very short bursts. These bursts, or pulses, they move through the atmosphere at the speed of light, which is 187,000 miles per second. Each transmitted pulse only lasts 1.57 millionths of a second, and the radar sends out 1,300 pulses every second. There's about 1 millisecond between each pulse when the radar listens for the returns. Now, in my opinion, the most interesting fun fact about radar is that it devotes the vast majority of its time to listening for those reflections. During 1 complete hour of operation of a weather radar, it transmits energy for less than 7 seconds. Now, of all the radar products, reflectivity is probably the easiest to understand. Precipitation reflects energy back to the radar, and the colors on the screen represent the size or intensity of the raindrops, hailstones, snowflakes, etc. Now, this rainbow of colors translates to numerical values used to express the number and size of water droplets. These units are called dBz. Now, with a few exceptions, the higher the reflectivity, the heavier the precipitation. Now, generally speaking, we can assume that 0 to 20 dBz is very light precipitation. 20 to 40 dBz is light precipitation. 40 to 50, moderate precipitation. 50 to 65 dBz is heavy precipitation, and anything greater than 65 is likely going to be extremely heavy precipitation, including water-coated hail. Now, finally, the most important thing that a radar user must know is that the radar truly doesn't know what it's detecting. All a radar does is send radio waves out in all directions and listens for those waves reflected back to the antenna. What we see here is a perfect example of a radar display showing what look like thunderstorms when in reality there's not a cloud in the sky. All of this was happening on a beautiful sunny Texoma morning. Now, scientifically, the explanation is anomalous propagation by superrefraction. It happens when specific atmospheric conditions bend radar beams closer to the ground, and the radar waves bounce off of things moving close to the ground, like bugs, birds, and the blades of wind turbines. Now, the first clue that these are not storms is that, well, they're not moving. Also, of course, we know where the wind farms are here in Texoma, but it's important that the meteorologists check other sources, the satellite, maybe surface observations, just to confirm that what this is in fact ground clutter. And of course, they won't have to worry about adding rain to the forecast. Join us for another episode of Radar School next week. For Texoma's Weather Authority, I'm John Cameron.